Okay, so today we'll be solving this problem. We'll be looking for the total electric force on this atom right here, and they all form an equilateral triangle. So we'll start by doing a free body diagram of the atom. Okay. So since this one's positive and then this one's negative, we know that they will attract each other, so the force will be going this way. And I just labeled this one A, and then this one B, and then this one's Q. So this force will be the force of B on A, and then these two are positive, so they'll repel, which means there will be a force going this way. And this one is the force of Q on A. And we know that this is 60 degrees, so we also know that this is 60, and this one is 60. So we know that this right here is 60 degrees, and we know this one right here is 60 degrees. And since these both have an x and y component, we have, this is the y, which is in the negative direction, and this is the x, which is in the positive, and then we have this one's y, and then this one's x. So we'll just label them x, f of q on a, y, and then we have f of b, a in the y, and then this one's f of b, a in the x. And so we're trying to find the total electric force on the 7 microcoulomb atom right here. And so we have our formula right here, and since these have an x and y direction, we will need to use our SOHCAHTOA. And so we know that our we'll start with f of q on A, and we know that our f of q on A in the y direction will equal f of q on A times I'll do these ones right here. We know that the f of q on A in the y direction will be that times the sine of 60, because we have our opposite and we have our hypotenuse, which is the q of A. And then our f of q on A in the x will equal f of q on A times the cosine, because we'll have the adjacent and then the hypotenuse. So the cosine of 60. And since we have the both x and y, we know that we can factor those two out, since the x and y components are positive. When we put the numbers into our formula, we can factor them out. So this will be the charge of q, and this will be the charge of A all over distance squared, and we can factor them out. Since we know they're both positive, we'll just do the cosine 60 plus sine of 60. And this should give us our I hat and j hat components. And once we put in the numbers for that, we will have equals 8.99 times 10 to the power of 9 times our Q, which was 1.8 microcoulombs, times 10 to the power of negative 6, and then our A, which was 7 microcoulombs. And then it's all over the distance, which was 0.41 meters, and then we'll square that, and then we have the cosine 60 plus the sine 60. And once we do all of the calculations, we should get f of q on A equals 0.3369 I hat plus 0.5836 j hat. And this is just part of what we'll need to get the final answer. And so we will do that same thing, but for the other force. So we'll do the force of B on A, which equals the same 8.99 times 10 to the power of 9 times A, which is our 7 microcoulombs. And then we have our force on our charge on B, which is minus 4 microcoulombs, but we're looking for the magnitude right now, so we'll just do 4 times 10 to the negative 6, and then it's all over the distance. And then for this one, we have the y and the x, except we have our 60 degrees right here, and we will use that 60, so we'll have this one, and then we'll have this one. So for our x, or our I component, we will have the cosine, so it'll be cosine 60, since we have the hypotenuse and the adjacent. And then for our y component, our y we can see is negative, so we'll subtract the sine of 60 because it'll be opposite over hypotenuse. So we'll subtract our y component. And once we do all the calculations for that, we should get 0.7487 I hat minus 1.2968 j hat. And since we're looking for the net force, our net force will be our force of Q on A plus our force of B on A, and we will just do the vector addition, so it will just be this number plus this number, and then this number plus this number. And once we do that, we should get 1.0856 I hat minus 0.71 minus 0.7132 j hat. And to find the actual force, we'll use our Pythagorean theorem, and we'll do the 1.0856 squared plus 0.7132 squared. We'll square root that to get our actual force, net force, and that will be 1.2989 newtons. So that is the answer to our first question. And then the second part is to find the direction counterclockwise from the positive x direction, which we can easily do. Now that we have the x and y components, we do know that tangent of y over x will equal that. Will equal our theta. Oh, inverse tangent. Okay. And so when we do that, we end up with our y being 1.0856 over our x. Oops. Nope. Our y is the 0.7132, and then our x is the 1.0856. And then that should give us our theta. So from there, this should equal 33.303, and that is, so if this is our axis, and this is our force, it gives us this angle, but what we want is this angle right here, so we just subtract that number from 360, which will give us 326. 326.697. And that is our theta from the positive x-axis right here.